Now that we know how to identify x and y intercepts from a graph, let's look at them a little closer. What is true about the coordinate of every single x-intercept? Well, we already know that the x-intercept is always on the x-axis, just like you see on the two graphs in front of you. So if a point is always on the x-axis, then we know that the y-coordinate must always be 0, since it doesn't move up or down from the x-axis. So that's what's true about the coordinate of every single x-intercept. The y-coordinate of every x-intercept is 0. Now let's look at what's true about the coordinates of every y-intercept. If you look at the y-intercept, we know that it is always on the y-axis, which means this time the x-coordinate must be 0 since it doesn't move left or right from the y-axis. So it doesn't matter what the y-coordinate of this y-intercept is. We know that the x-coordinate is always 0. So let's write that down. Cool. Now that we know this, we can go ahead and use this knowledge in order to find x and y intercepts from equations. So let's try number 3 all together. We have this equation, 5x minus 2y equals 10. And we need to find the x and y intercepts. Well, let's work with the x-intercept first. We know that the y-coordinate of every x-intercept is 0. So if the y-coordinate of every x-intercept is 0, then I can plug in 0 right here into the y-coordinate and solve for the x value. Oops, 5x minus 2 times 0 equals 10. Well, 0 times anything is 0, so we really just have 5x equals 10. So if we divide both sides by 5, we get the x-coordinate of the x-intercept, x equals 2. So that means our x-intercept is the ordered pair 2, 0, since the x is 2 and the y is 0. For the y-intercept, we can do something similar. This time, I'm going to plug in 0 into the x, since I know that the x-coordinate of every single y-intercept is 0. So this time, I'm going to say 5 times 0 minus 2y equals 10. 0 times anything is 0, so really this is negative 2y equals 10. Divide both sides by negative 2, and we get y equals, negative 5. So the y-intercept for number 3 has the ordered pair 0, negative 5. So here's the y-intercept that we found, and the x-intercept that we found. Whoops. That's better. So just like I did number 3, I would like you to pause the video and try numbers 4 and 5. All right, here's a reveal for number 4. To find the x-intercept, remember I need to plug in 0 into my y in the equation. So I'm going to say negative 3x plus 5 times 0 equals 30, which means we have negative 3x equals 30. Divide both sides by negative 3 in order to get x equals negative 10. So the ordered pair for the x-intercept is negative 10, comma 0. Then for the y-intercept on number 4, I'm going to plug in 0 into the x, since the x-coordinate is always 0 on the y-intercept. So this time I have negative 3 times 0 plus 5y, oops, that's supposed to be 0, equals 30. That means 5y equals 30. And if we divide both sides by, whoa, if we divide both sides by 5, we get y equals 6. So the ordered pair for the y-intercept in number 4 is 0, comma 6. And here's my reveal for number 5, for the x-intercept. We're going to plug in 0 into the y. So 4x plus 2 times 0 equals 16, which means 4x must be 16. So if I divide both sides by 4, I get x equals 4. So the ordered pair for the x-intercept is 4, comma 0. For our y-intercept, I'm going to now plug in 0 into the x value. So 4 times 0 plus 2y equals 16. That means 2y equals 16. And if we divide both sides by 2, I get y equals 8. So our ordered pair for the y-intercept is 0, comma 8.